Okay, today's lesson's looking at random. What does it look like? So there's a short cartoon there, which I'll give you a chance to look at. So this is an interesting cartoon because random is a thing that is notoriously bad for people to understand and what people and apply to the real world. So what we have in this cartoon is an example of a lightning strike and two people out on a golf course or something like that, asking should we go inside, um, and then the response being it's okay. Only 45 Americans a year have a chance of dying, so that's 1 in 7 million. Let's go on. And then the cartoon points out that the annual death rate of people who know that statistic is actually 1 in 6. So just by knowing that statistic, suddenly that changes the probability, which does seem a little bit strange. But when you think about random, random means that you don't do anything based on any information. You just act in a random way. That there's no sort of idea, and that is pretty much normal. So what that means in this instance is that the 1 in 7 million is based around people just randomly acting the way they do. As soon as they're making a decision or getting influenced by something, suddenly it's no longer random. You're no longer like the rest of the population. You're suddenly acting in a different way. So the fact that he knew that statistic means that he had more confidence to stay and say we're not going to get hit by lightning, actually changed the chances of him being hit by lightning. Um, so while it's quite comical, it's also true that if you, and we've talked about risk as well, is that by knowing that statistic, it improves your confidence. So therefore, you're more likely to be hit by lightning. You're more likely to stay outside when you shouldn't, because what most people do is that they go inside. Um, so that's really interesting about randomness because it appears like most things around us are random. Um, and actually, if we can work out they're not random, it gives us an insight and gives us helps us along the way of being able to have a greater understanding. So an example I've got here in World War II, the Germans developed the first missiles, the first of which was the V1 rocket. Um, and here's a picture of what it looked like. So it had a jet engine at the top, which you could hear. Funnily enough, I was talking to my grandmother about this today, who is a Londoner and remembers them coming along. And she described to me hearing the sound of the rocket, and then when the engine stopped, uh, it basically meant that the rocket was going to dive and hit their target. And unfortunately, my great grandparents got killed by a bomb, not a V1 rocket, but by these sorts of things as well. So obviously, this was a real problem in London. Uh, people, but the thing people wanted to know about them is how much control did the Germans have with the V1 rocket? Was it that they were randomly being sent in, and um, uh, wherever they hit was where they hit, or was it that there was an actual pattern? Were they targeting things, and could they control that targeting? So that's quite a vital piece of information because it sort of meant that you could evacuate people from areas if you knew that they were targeting specific points and things like that. So another interesting website you can look at if you want to. The link's at the top there. I'll also put it in the lesson page. Is that over time, and the Germans were particularly good at recording this information about where the rockets were hitting. So here we've got is a map of all the bombs and rockets that hit London, and you can try and see it. And the idea was to try and see if there was any patterns. So in fact, during the war, this was someone's job to go through and try and see if they could see if the Germans were targeting particular areas. So if we just take a brief look at it here, you can see some clusters of bombs and things like that along there. But in general, it kind of looks like a bit of a random pattern. There's no real pointer or control. And that's because our understanding of what random should look like is a little bit skewed. We tend to think of random that there's an even coverage, that if we see particular clumps together, if we see a particular area that doesn't have as much things in it, that it may not be, that it's not random. And when the actual opposite is true. In random patterns, you're more likely to see things clumped together than you are to see an even spread. Even spreads tend to be an indication of something being not random. So here's a case in point. One of these is stars in the sky, or the pattern of stars in the sky. The other one is looking at glowworms in the Waitomo caves. So have a look at them, especially of what I've just talked about, and see if you can predict which one is the stars, which one is the Waitomo caves. Okay, hopefully you've decided on your one, no changes. So the one on the right is the glowworms, the one on the left is the stars, which kind of looks like, which in our mind doesn't suggest that it's random, because there's all these big areas where they're clumped together and we've got all these big gaps. And it's a bit like, and whereas you look at the glowworms, there's much more even spread. There's none of them really clumped together or anything like that. But when you think about what influences where they appear, it actually makes a lot more sense that glowworms wouldn't have a random pattern. And that's because they're actually competing. Each of those dots represents one glowworm that's competing with another glowworm for food, space, resources. So they would naturally try to even themselves out. I would suggest that these gaps tend to be the crevices in the cave that naturally mean that those glowworms couldn't be together. Where stars, there is no restriction on a star. There's nothing influencing a star being in one particular place compared to the other, because the distances are so far together and we're so far away from them that it's really hard to see. So the stars are an example of a random pattern that has lots of groupings together, where the glowworms are an example of a non-random pattern where there's a set reason. So, and the key thing is that the glowworms are just like the people out on the out in the field with the lightning strike. And the people in the lightning strike were influenced by the statistic they knew. The glowworms are influenced by the glowworms are influenced by the fact that they need space to live, whereas the stars, there is no influence on them at all. They are where they are. So here's an example of predicting whether something's a random pattern or whether something is made up or predicted. So this is a task. There are 8 people in a class, or probably more, but we've got 8 people's answers from a homework task, which asks them to flip a coin 100 times. Now, we know that 7 of these people did it properly, had a coin, flipped it, recorded the results, and then did it. But one person we know cheated, and they just made up their random results. So looking at the data, is there a way that we can predict who is the cheater? So I'll give you a bit, you can pause the video, or I'll give you a bit of time to look at all 8 of them to see who is the cheater. So the big question, who is it that cheated on their homework? Who didn't flip the coin 100 times and just made up some answers and tried to make it look as if it was random? And the answer is Earl. So hopefully some of you got that as your answer. So the next question is, what is it that makes Earl's question or Earl's answer that we know that it's fake? Okay, so there's a couple of things that we can look at. One of which is that if you actually look at the numbers, there's 50 heads and 50 tails. Okay, while that's something we would expect to happen based on their probabilities, it's actually very unlikely to happen. So that's usually a clear sign that we've got something that is not random. The other thing is that you can see the biggest group of reds that we have is 4 in a row, and the biggest for the tails is 5 tails. You'll notice in most of the other random values we've got 6 tails there, and we've got a large one here in Robbie's one with looking at that as well, and then a single, and then more heads. That there's just not enough grouping. It's looking like it's spreading out, and that's kind of a natural thing to do as you're thinking about it. That you're thinking, well, actually, I've had 5 heads already. I must be due to have a tails, and that's quite it's quite a common misconception about randomness. Is that if it's truly an independent event, it should have no effect on the previous one. So the fact that you've had 10 heads previous shouldn't change it. Shouldn't change the fact that you end up with. It shouldn't change the fact of what the next one's going to be. So these were some of the answers that were given to this task online. So I think Earl is the cheat because heads and tails are pretty much equal, as if he tried too hard to simulate the random pattern. Another way of telling Earl is the most likely to be the cheat is that there's no strings of repeat results of 5 or more. And when you realize that there are 95 strings of consecutive results, meaning first, second, third, fourth, sixth, second, fourth, fifth, sixth, seventh, third, fourth, fifth, sixth, and eighth, you might find it suspicious that long strings of repeated results don't appear at all. So the fact it is very difficult to predict, to make something look random when without generating it using a computer or something like that. And this is quite an important, this is very important in this case, about predicting about behavior and things like that, especially people who are trying to manipulate systems and things like that. So Dr. Harold Shipman is a infamous doctor in the UK who was found guilty of the murder of 13 patients under his care. It's also suspected that he murdered 250 patients over 23 years. So he was caught in the mid-90s. He was just a local normal GP, and he was giving patients wrong medications and murdering them. Now, he was obviously caught, but they also found that by doing a simple bit of statistical analysis may have caught him a lot earlier. And that's basically using this graph. So it's basically trying to see the difference between the normal or random and then what someone who's manipulating the system. So I'll explain this graph. So there are two lines. The first line is the comparison. That's the normal GPs, and this is the percentage of deaths and the time of day that they happened. So that's the normal line. Now, if you actually look at this doctor, you can see his line, the black line. There is actually a peak, massive peak between 12 and 8 p.m. Which is also the time that he used to do his rounds and go into people's homes. So while just looking at the data, it would look like that these deaths were happening randomly, because the numbers were so small compared to the number of deaths. Remember, the important part is this is a percentage. So while there might be 10,000 UK GPs, and there might be 2 million deaths or whatever it is, okay, if you actually compare their percentages, he's having most of his, or 15%, almost close to a fifth of all his deaths in working hours between 12 and 8. When the other GPs, it's a bit more random, that it could happen anytime. And that's because he's going away from the randomness by actually administering drugs he shouldn't be administering and things like that. So by just looking at this data, this was used in the end as part of the conviction part rather than him being caught. So that's a really important piece of statistical analysis that you can use, or was used in catching this guy, convicting this guy and putting him in prison. So the randomness is really important. So again, if we go back to our V1 rocket, if we just look at the dots, they appear to be all over the place. However, if we change the analysis a little bit and then look at the number of hits within, so what they did is they then took the map and they divided it into squares. Rather than just looking at individual dots, they looked at how many dots were in these squares. Now, obviously, the squares were a little bit smaller, but it showed the intensity. And what they could actually see is that there were peaks. There was a peak that was in the north, must have been in the southwest. Okay, and so that what that meant is that most of the bombs were going to one particular place, which meant that the Germans were actually had the ability to target them, which was a vital information. Then they could move, and whenever they saw the V1s coming, they knew where they were going. So that was vital in the war effort. So that's taking something that appears to be random, and then suddenly we get information that it's not random at all, that it's predictable. One last thing I'd like to have a go at is there's a link again in the OneNote lesson page at trying to predict, trying to make something appear to be random. So there's a link to a website, and all you do is you get it set up, and what you're trying to do is by clicking heads or tails, you are trying to create a random coin toss. Now what you'll see is that as you go through, it will then tell you whether your sequence looks random or not. And you can see by doing big groups here, what I've ended up doing is making it random, and then suddenly it changes to less fake. What the trick of the game is to try and do it, get to 200, and have it say that they think it's that you're really doing it. You could also do it by flipping a coin and actually seeing whether it's real or fake. Whether the computer will predict and work out that you're actually doing a real random coin flip or not. So have a couple of goes at that, just so you get an idea. But even a computer can predict whether something, and it is accurate, whether you're actually flipping the coin, or whether you're trying to trick the computer that you're flipping the coin. If you want to go into greater details, it talks about streakiness and all those sorts of things, which are important as well. Here's some references, particularly to an article which I got most of this information from, and also the link to the fake or randomness. Okay, go back to the OneNote lesson page and complete the tasks that are on there.